Imagine this, you are in a meeting. Data analyst presents results and says this experiment is statistically significant. Everyone nods. Decision is made. Feature gets launched. Weeks later, nothing changes. No real growth, no meaningful impact. So, what went wrong? The data wasn't wrong. Analysis wasn't wrong. Interpretation was wrong. Because one critical question was never asked. Does this result actually matter? And that's exactly what we are going to fix today. Welcome back to Shital's Data Desk. I am Shital, and in this video, we will break down what p values really mean, what effect size tells you, and why relying only on p values can be misleading. We will also compare both concepts clearly, connect them to real world decision making, and uncover most common mistakes people make in data analysis. By the end, you will not only understand difference, you will know how to think like real analyst. So, let's start simple. What exactly is p-value? A p-value answers one question. If there was no real effect, what are the chances we would see this result just by luck? That's it. So, when people say P is less than 0.05, what they really mean is this result is unlikely to be random. But here's where most people go wrong. They assume small p value means result is important, effect is large, decision is obvious. But actually, none of this is true. P value does not tell you how big the effect is, whether it is useful, whether you should act on it. It only tells you something is probably happening. And there's another big problem. P values are heavily influenced by sample size. If your sample size is small, even a large effect might not be significant. If your sample size is huge, even a tiny, meaningless effect becomes significant. So, p values are really about certainty, not importance. Now, let's talk about what actually matters, effect size. Effect size answers completely different question. How big is the change? Let's look at two scenarios. Scenario 1, conversion rate goes from 10% to 10.1%. Scenario 2, conversion rate goes from 10% to 15%. Both could be statistically significant. But do they feel the same? Not even close. That's the difference effect size makes. It tells you magnitude of change. Think of it like this. P-value questions, is the signal real? And effect size questions, how strong is the signal? Effect size connects data into decisions. Because in real life, decisions are made based on impact, not just statistical validity. Now, here's where things get dangerous. Imagine you run an experiment on 1 million users. You find conversion increases from 10% to 10.1%. P value is less than 0.01, statistically significant. But let's think about reality. Will users notice? No. Will revenue meaningfully change? Probably not. Could implementation cost more than the gain? Very likely. This is the trap. Large sample size gives you tiny p value. Tiny effect gives you negligible impact. And yet, result looks statistically impressive. This leads us to wasted resources, wrong product decisions, misleading conclusions. So, if you rely only on p values, you might detect something but completely misunderstand it. Let's simplify everything. P value measures probability. It depends heavily on sample size. It tells you if result is likely real, and it does not measure importance. On other hand, effect size measures magnitude. It is mostly independent of sample size. It tells you practical impact. It drives real world decisions. Together, they answer, is it real and does it matter? And you need both, not one. In real life, nobody makes decisions based on is it statistically significant? Instead, decisions are based on is it worth acting on? Let's say you run two experiments. Test A plus 0.2% improvement. P value is less than 0.05. Test B plus 15% improvement. P-value equals to 0.06. If you blindly follow p-values, you pick test A. But if you think like real analyst, you seriously consider test B because 15% improvement is massive. It might just need more data to confirm. This is the key insight. Statistical significance is not equal to business value. The most common mistake in data analysis is celebrating statistical significance without checking effect size. You will hear things like we found significant improvement. But when you look closer, improvement equals to 0.1%. That is not insight. That is noise dressed as insight. And acting on it leads to poor strategy, wasted effort, false confidence. So always ask, how big is the effect? Here's the mindset shift that separates beginners from real analysts. Beginners ask, did something change? Real analysts ask, did it change enough to matter? And here's a powerful sentence you can use in real life. Yes, the result is statistically significant, but the effect size is small, so the practical impact is limited. That one sentence instantly shows you understand data deeply. One more idea that separates average analysis from really strong analysis: uncertainty. Let me explain this with example. Imagine you are testing new marketing campaign and your analysis shows revenue increases by 5000 pound. Sounds great, right? But here's the catch. That estimate is not exact. In reality, true impact could be anywhere between 500 pound and 9500 pound. Now think about that. That is a huge range. In one case, it is barely useful. In another, it is massive win. That uncertainty makes decision making difficult. Now compare that with second scenario. Same estimated impact, 5000 pound. But this time range is 4800 pound to 5200 pound. Now that is very tight, much more predictable, much easier to trust, much easier to act on. So, the real question is not just what is the expected impact, but also how much can it vary? Because in the real world, decisions are made on confidence, not just numbers. So, always think in two steps. How big is the effect and how certain is that estimate? So, now let's connect everything. P value tells you if something is real. Effect size tells you if it matters. Uncertainty tells you how sure you are. Together they give you complete understanding. Without effect size, data is incomplete. Without uncertainty, data is risky. Before you leave, I want you to remember just one thing. Not every significant result is worth your attention because data doesn't become valuable just because it passes threshold. It becomes valuable when it changes decision. So next time you look at any result, pause. Don't just ask, is this statistically significant? Ask yourself, would this actually change what I do? Because that one question is what separates noise from insight. If this video changed how you think about data, make sure to like, share and subscribe to Shital's Data Desk. Thanks for watching and I'll see you in next video.